We're talking about APIs and bucking the trend, and particularly what Netflix is doing.
Yeah.
They actually did a bunch of scripting benchmarks and chose Groovy, which is interesting because it's not the most popular scripting language.
That's right.
But I think you guys had good experience with it.
Groovy.
It's more of a California thing. Yeah,
Yeah, that's right.
In New Jersey, it's just cool. You know.
Yeah.
Hello there. Thanks for being patient. I'm Greg from Apogee.
I'm Daniel Jacobson from Netflix.
And we're going to get started. First thing we're going to mention, just real quick, getting a lot of interesting traffic on the API Craft group. A lot of you participate. It's a great place to discuss all kinds of aspects of APIs, from API design, API security. There's a lot of debate going on there about various ways to build new frameworks for REST-style APIs. There's a lot of design questions. It's been an interesting group. There are a lot of people. Please do check it out. I'll also mention real quick, and then we'll get the promo section out of the way, Apogee's YouTube channel. This presentation, including the slides, the audio, and the video that you can't see now that we're making, will be posted to the YouTube channel usually a couple of days after the webinar's done. Slideshare.net, by the way, is also where these slides will be available. So that's another place to hang on to. And that's for the inevitable question, how do I get the slides? That is the answer. And finally, it would be remiss of me not to mention that Daniel and I did write a book together along with Dan Woods entitled API as a Strategy Guide. It's an O'Reilly book. Is that a Rosie Starling? I've already forgotten.
What it is. Yep.
It's the Rosie Starling O'Reilly book. A lot of the stuff not a lot of the stuff. Some of the things we're going to discuss today are in the book. Some of them are not. And it was a lot of fun writing. We wrote it over the last year, and a lot of you have read it. So thanks for the feedback, and looking forward to doing more. So that's it. So I'll just mention really quickly. I'm Greg Braille from Apogee. I've done a whole bunch of these webinars.
Daniel Jacobson from Netflix. Those are our Twitter handles if you want to follow us or ask us questions afterwards.
And that is actually us. We thought about hiring models, but we decided in the end we would actually use ourselves. So there you go. So let's get started with some of the content. What we're going to do, here's the basic structure for what we're going to do. We're going to talk about the trend, which is the way that we see a large number. I was going to say a majority. I'm not a real statistician, but it seems like a majority. Certainly the majority of the ones that I see, public APIs and private APIs. What are some of the design styles in which they're built? And if we look at this slide, a lot of it is stuff that we talk about on the Apogee webinars all the time. If you watched a Brian Malloy webinar, for instance, about API design, or read the API design ebook, there's a certain style that people follow. And we're going to go into details about each one of these things. There's the pragmatic REST style. There's the idea of having one API for everybody. There's the use of JSON, use of OAuth, API versioning somehow done in the URI, or if not in the UI nearby. And we'll go into details about each of these.
Yeah, in addition to that, we're also going to talk about bucking those trends. And in specific, Netflix, we recently redesigned our API, and we actually bucked most of these trends. And so we're going to go into detail as to what we did, why we did some of those things, and we'll kind of interlace our case study in line with the trends.
Exactly. So the structure is going to be, we're going to talk about each one of these trends, describe them, say what they are, then why would you want to follow them, why would you not want to follow them, what did Netflix do, whether you should do what Netflix did or not, and that's going to be the basic structure. So let's get started. First trend. This is a trend in need of a name that we can all agree on. But if you look at a lot of the public APIs out there, look at a lot of the APIs we work on at Apogee, follow some of the API design webinars we've done, there's a very clear trend, especially in public APIs, to what we have been searching for a name for, but a lot of us call pragmatic REST. Some people say RESTful, which is different from REST. I don't want to get into that debate. But so rather than getting into a terminology debate, let's describe what it is. It's an API in which there's a carefully designed URI hierarchy, and each URI represents a resource. And I'm not going to go into gory details about this because you can read Brian Malloy's ebook, for instance, to get a lot of the examples here. But in a pragmatic RESTful API, you spend a lot of time designing your URI hierarchy. You'll have something like, /customers/foo gets you the record for customer/foo, and delete customer/foo removes it. and post customers creates a new customer, and so on and so forth. So these are kind of the high-level tenets, in my opinion. You carefully design your URIs. Each one is a unique resource, and then you have actions on those resources defined by the HTTP verbs.
Yeah, and another implicit part of that is a granularity to the modeling, so that each resource is really focused on solving one problem set.
Right.
And there isn't so much of a blurring of the lines there.
Right. So in a Netflix API, a movie might be a resource. Mm-hmm. And you might, but you wouldn't delete the movie as a user. You'd get the movie, but then the title, the descriptions, and I think people may have seen the design of the public Netflix API. It's very much like this. So what are some alternatives to this? And I'm actually going to talk a little bit about pure REST, and then we'll talk about some of the other alternatives. And this will lead us, I think, to the sort of bucking the trend part of this presentation. In a pragmatically RESTful API, you can design it however you want. But what tends to be done is that resources do tend to be very granular. In the worst case, you want to get a list of all the actors in a movie, and you have to make an API call to get information about the movie, and another one to get the list of actors, another one for each individual actor, so on and so forth. The resulting API is, in my opinion, very easy for a developer to learn and to use, but what you end up doing sometimes is making compromises in order to make the API more efficient. So there are some alternatives here, and let's talk about some of them. I'm not going to spend a lot of time talking about sort of the ad hoc XML JSON over HTTP API. That's, not really an API design. It's kind of more like, well, we didn't want to use SOAP, so we have some URLs and we have some XML, and things just kind of work. There isn't really a coherent design to it. So that's not really a pattern. SOAP is another pattern, very mature. We've talked about it in the past. Lots of tools for it. Works great if you have a big enterprise stack like a J2EE app server or .NET on both sides of the equation, and you're comfortable using those tools. There's a lot of SOAP out there. SOAP was huge a few years ago, but I'm also not going to spend a lot of time talking about the SOAP alternative. I will talk a little bit, and this is as much as we're going to talk about REST in this webinar, I think. About one alternative is to use pure REST. And if you look at the API Craft group, there is a huge amount of discussion right now about what's the best way to do this. A pure REST API is one that follows everything that was defined by Roy Fielding in his famous dissertations and Roy Fielding's followers. They believe, for instance, that a REST API is not just a bunch of URIs and resources and verbs, but you have to follow a very specific hypermedia style to use the API. So rather than just getting the list of movies, first you would look up something about the Netflix API, and that would tell you the URL to get a list of movies. And then for each movie, it would tell you the URL to get information about that movie. And then you'd look at the response for that and figure out what URL to get the list of actors, and then figure out what URL to get the next actor, and so on and so forth. So the result is a flexible, powerful API. You can change the URLs on the server side. You can change the URLs on the client side. There's all kinds of great stuff that you can do. I think it's a really interesting concept. It is how web browsers work on the World Wide Web. So yes, it scales. It is not how a majority of public APIs work. In fact, it's not really how any public APIs work. And it requires even more granularity. You end up not only having lots and lots and lots of resources, although you can design it any way you want, but a lot of links. And your API is now designed, the design of your API is now not a design of URI hierarchy, it's a design of link relation hierarchy. So you still got to design it. You still got to document it, in my opinion. Some people say you don't have to document it. I don't see how that could possibly be true. But it is a different way of designing an API. It's a way to buck the trend. I don't believe you guys are doing this.
No, and one other detail that's worth pointing out is that if you do go the pure REST route, as you kind of alluded to, but just to be more explicit, it does result in a highly chatty interaction model between the requesters of the API and the API itself. And so when we get deeper into this and start talking about the Netflix scenario, chattiness is something that is quite a concern as we evolve.
So this is kind of teeing up with what you guys are doing, but if you now I know that you can design a REST API that does anything you want, But generally speaking, the idea of having one URI to a resource, whether it's accessed via a hierarchy of URIs that are defined in a document somewhere or in an API console, like a lot of the APIs that we see today, or whether it's described in link relations, which would be the pure REST alternative, it's still a lot of individual resources. And I think what you're saying is, for you guys, that was too many.
That is exactly what I'm saying,
Okay.
and we'll get into detail about that in the next section.
Cool. And the point of this slide is just to say that most APIs that call themselves REST, if you crack open PhD dissertations and go to the right corners of the internet, people will tell you that they're not REST. And they're right. That doesn't mean there's not an API design style, which we sometimes call pragmatic REST, which is very common on the internet. I'm going to move on from this topic, because this can be a fun but also highly charged topic, and move to what's going to be probably a little more meaty on this thing, which is the trend towards one-size-fits-all.
So the one-size-fits-all model is basically, in my view, the trend where an API team is building out a single API to satisfy n number of users, and there's a lot of commonality in the way that all of these users are going to interact. So the question is, does it make sense to have this one API that all developers can leverage? So the benefit, or the why yes, as the slide says, is API team can focus on solving exactly one problem. Building an API that's very granular. It's representing the resources and the data that you have. You can document it and then basically publish that out so that all of the developers can just look at the documentation and go. That does have value in terms of the training costs of the development teams who are going to be leveraging this. They can leverage each other's libraries potentially, and there's a lot of commonality you can benefit from there. And because the API is servicing everybody basically the same, it can support an unlimited set of people, developers, both in-house and outside, whether they're partners or public developers. You can treat them all roughly the same.
So I think you're going to spend a bunch of time on the why no. So let me just spend a few minutes
on
the why yes. Because generally, I think this is what I end up advising a lot of people to do when they're designing their APIs, which is build a good API, be proud of it, have it be well documented, document your URIs and your parameters really well so that anybody, any third-party developer or internal developer or partner developer can ask themselves, how do I use my API in the organization? I want to launch a new device. I want to build a new app. All they should have to do is go to a web page, read the docs, start building. Whether you use pragmatic REST or Roy Fielding REST with Helios or SOAP, that principle should apply. And I think what you're going to argue is that, in your case, that isn't what worked. So I'm curious to hear.
That's right.
Some of the alternatives.
Before we go on, I just want to follow up with what you're saying, which is I agree that this scenario works for a large number of the people who are interested in API development. What I'm going to talk about here is some of the calculations that we made internally, some of the things that are potentially very unique to Netflix, or maybe to Netflix and a related set of other people out there that cause us to want to buck that trend and find something else. So some of these things that I'm going to talk about may resonate with what you're going through and may make sense for you to question the REST approach. It might not, and there's a lot of value in continuing with the trend in this. So moving on to the why not.
Why not?
So what we have found at Netflix is there is a lot of value in treating them all generically, all these clients that are going to leverage the API, but what you're doing then is optimizing for none of them, which becomes a challenge, especially when you're dealing with a large number of teams or different devices that are going to be using the API. But in addition to that, the API team becomes a bottleneck for UI development, because what you're going to find is as more people are making more and more requests from different scenarios and different use cases, the API has to evolve in different ways. All those requests are coming in. How are you going to balance whether I'm going to do this one or that one? And ultimately, if you don't build up your API team with a lot of engineers, then what you're going to be doing is turning things away or delaying on building that stuff
people
out.
are building suboptimal clients, is I think what you're saying.
Yeah, that's another scenario. So this slide here is really just meant to represent the breadth of devices that Netflix currently supports. I think the number now is about 800 plus different device types. In addition to that, the public API, which is the 1,000 flowers in the bottom right corner. So I bring this up because this does put us in a unique situation, or maybe not unique, but in a scenario where most people are not at. A huge breadth of devices basically results in seeing a much more variable set of capabilities and requirements across these devices. So some of the differences you might encounter when trying to support this number of devices is memory capacity. Some of them cannot handle as much data as you transfer it across. Some of them actually require different markup types like XML, JSON, or some of it might be proprietary XML that you have to custom develop for them. So in some cases, you have UI teams that are part of your company, as we do at Netflix, but sometimes we're also interacting with partners that have markup restrictions for us. Some of them actually perform differently based on a hierarchical or a flat markup model. And so we've done some analysis on some of our UIs, and it does turn out that some of the devices perform better with different markups, which means that you have to yield a different set of data or a different markup for a specific device.
So you have, are most of the UI teams, are they within Netflix? Are they external to the company? So is there a mix?
Most of the UIs at Netflix on these devices are built by people down the hall from us, so Netflix employees. Some of them are built by partners or in collaboration with partners. Some of them are built entirely by the partners.
Right.
But for the most part, the majority is Netflix employees.
And what's the typical request? Will they come to you, or in the previous, because we're going to talk about how the API is evolving too, but in the previous generation, would they come to you and say, love your API, we need this XML?
It would be more like this resource, we're building this screen. This resource is the majority of the screen, but we want this other bit of data on this other resource, and we don't want to have to make this other call. Can you extend and collapse those into another blend of a new resource with an expand? And so there was a lot of work around expands and customizing that type of
batching.
stuff.
Yeah, I mean, as I recall, one of your goals was for one screen like this, essentially one API call per screen.
Yeah, and we'll talk about that in a minute.
Okay, I'll go back.
We'll get there. Let's finish up this, and we'll get to that. So other differences, screen real estate, that results in, how many titles are displayed on a screen, or what kind of metadata you can surface. Some of them actually want different forms of delivery of the document, whether it's progressively rendering or full document delivery.
So document meaning image files, audio files?
No, I mean the markup document.
Oh, really? They want progressive delivery of the markup document?
In some
That's
cases.
Interesting.
Yep. So as resource information becomes available, just get it up. Don't wait for another dependency.
So you actually stream it out to the device in like a little bit at a time to reduce the latency?
In some cases, that is preferable.
Huh? That's very interesting.
And then, of course, different user interaction models across devices could influence in some cases. For example, Xbox has the Kinect, and you can do the hand motions and voice motions. Or voice commands, whereas the Wii has the pointer, iPhone and iPad have the swiping, etc. So those are some examples, and they actually grow as you incorporate more and more devices, and we're at 800 plus, and when you hit that kind of scale in terms of the device support, you're going to see a lot more of this. So Greg went forward already to show a little bit of these slides. This is just two examples, our basic PS3 and our iPhone display screens. Nothing magical here, but it's just to represent that they actually do display the landing screen a little bit differently. Some of the metadata is different, the number of titles is different. And the next screen shows the individual title screen. Okay. Similar in the fact that some of the data is the same, but some of it's different. Some of the presentation is different, and these are just two devices.
So if we were to look just at this iPhone screen on the right, we've got a list of titles. Each title we've got a date and a rating and a star rating and a cover image. Whereas over here we've got a whole lot of cover image, but we don't have as much information. I mean, basically, I think what you're saying is the challenge of designing a single REST resource that would do this without requiring 30 API calls to paint that.
Yeah, to optimally render that. Yeah. So in the previous world, it would be granular and REST-oriented, where to build that PS3 screen, there are a bunch of API calls just to build the base page, and then as you hover on each title, we have to fetch another set of data for each title.
Right.
And so there's a lot of transactions going back and forth. In the iPhone, it's similar, but it's a series of calls to populate the screen,
right.
Where you would say, get me these lists, get me these titles, and it would surface it all initially, so you don't have to make another fetch call after, but you're doing it all to preload the page. So it's a different interaction model to present it because the screens are different. Okay, so those previous slides really were meant to demonstrate at least some of the complexities, and
yes.
we have decided to move away from the one-size-fits-all. And here are some of the things that we determined were a good scenario for when you want to buck that trend and move away from one-size-fits-all. So quickly running through them, small number of targeted API consumers, and that is your top priority. So we already talked about Netflix UI teams being internally developing the UIs, and that is our top priority. So we know we fit the first one. Very close relationships between the API consumers and the team. We're very close with them, and even if it's a partner external to us, we're very close with them as well. Increasing divergence of needs across the top priority. We have 800 different device types. We already talked about the divergence. Strong desire by the API consumers for more optimized interactions. Well, they want to perform faster. They want to have simpler client-side code. So we know that we need to break down the one-size-fits-all model for that. And then there's a high value proposition to support that optimal model. And we think that there is, both in terms of our ability to innovate quickly, which we'll talk about shortly, in addition to potentially increasing the performance on all these different devices, rather than having them fight against server-side rules that we dictate.
Right, so that's why I was asking previously, for instance, because I actually did read the slides before the presentation, was that, where are these developers located? Do you think this model would be different if your developers were offshore or third parties or customers?
So if they're still top priority, if we still have a need for improving performance and innovation rates and things like that, whether they're located right down the hall or in India, that's probably not going to be a key concern.
Okay.
Because we have this interest in optimally developing and making sure that we can support that development. But it will create some challenges if they're not down the hall, just like anything that is 3,000 or 5,000 miles away.
Yeah.
So it would be better if they're down the hall, but I don't think that location and proximity is different.
Okay.
A defining characteristic. Now, if these developers are people that you don't have close relationships with, like a public developer where it's kind of more of a distant relationship, I think that would be a greater concern.
Yeah, I wanted to ask about the skill of the developers, but actually we're going to get to some more detailed slides about exactly how this is put together.
Yeah. So as we developed this, these were the 4 key principles that we put in place to drive our decisions.
Right.
So that is embrace the differences of the devices rather than try and treat them generically. Separate content gathering from content formatting and delivery. So they all care about the same content, but they care about it, presenting it in different ways to their UIs, so maintaining that distinction. We actually redefined the border between client and server, which I'll have a slide showing what that means. And then the other key is distributing the innovation at the API layer. And I'll have some visuals for that in a minute as well. So next slide. This was our previous model, the REST API
so this is,
world.
even though all the arrows are going to one circle, it's one size fits all.
It's one size fits all.
There's one API for all of those devices on top.
Yeah, the PS3 basically is an example where all those individual colored arrows represent different resource type calls or different transactions against the one-size-fits-all API model. Now, the way Netflix is structured organizationally is that we have a range of different other engineering teams who house the data, and the API itself is really just a broker for data. We don't store anything. So those individual calls loosely represent dependency calls to get the corresponding metadata.
Are these different in your current API? Are these different calls down here? Are they further API calls? Are they inside the Java object model?
It depends on the individual dependency. Some of them are kind of like a RESTful type call to a backend service. Some of them are more embedded in our JVM. We know how to handle it. Some of it is other kinds of request to caches or things like that. So there's
Right.
a range of different models.
Okay.
So in the new world, our intent is to have a single API call across HTTP or the network border back to a client adapter, which is a custom endpoint for the PS3 specifically. And then that adapter knows how to handle that incoming request, parse it out into all the dependency calls
Right.
on the Java side or on the server side, call corresponding Java APIs. Those Java APIs know how to get the data from the back end, deliver it back to the adapter, and then the adapter does the formatting. So the key here is that the adapter is a custom endpoint. It's only available to the PS3 potentially, or that it can be shared out, but it's an isolated call.
It's designed for the PS3. In fact, it probably is important that it's only for the PS3 because the PS3 team needs to change it.
Yeah, although sometimes the UIs, it's the PS3 UI, which is
Okay.
shared across other devices actually.
Okay.
So it could just be at
That's
a per
interesting.
UI basis. But the call comes in, that's a single call. The value there is that HTTP is going to be the most expensive part of the transaction. So we're reducing the number of transactions from people's homes to the server, which let's say on average is about 150 or 200 milliseconds for that request. Instead, we're pushing that down to the server. The adapter knows how to handle that, and then it calls back to all those corresponding Java APIs instead of having it all HTTP oriented.
Okay.
So instead of it being 150 to 200 milliseconds on average for call, we can get it to 10, 15, 20 milliseconds, aggregate it all up, progressively render it, or deliver the document at the end. And the other key here is that because it's a custom endpoint and the custom adapter, it can actually prune out the things it doesn't want. It can format it exactly how it wants, whether it's a flat JSON model or a very hierarchical semantic XML model, deliver whatever it wants back there, and they can develop that adapter code at the same rate and the same time as they can their PS3 code. So there's a close tie between those two things.
So the UI team working on the client UI is also working on
The
the adapter that runs on your server farm.
That's right. And in fact, the way they publish those adapters is, by the way, those adapters are Groovy. Our core application is Java. We have a JVM running up on however many instances in AWS. That's our base architecture. And they basically publish their Groovy scripts independent of the time that we publish our Java code base. They
Right.
can do it at any time. And what happens is they push it up there. We have a process that will distribute that Groovy code across an array of our servers and compile that Groovy into the JVM. So it's running as though it's Java, but it can be published independently of that. So if we go to the next slide,
Yep.
here's another key tenet is that in the REST API world, there's a clear divide between client code and server code. The client code in this scenario is basically everything on the client devices themselves, and the server is everything on the server. In our new world, we've redefined...
So, sorry, this is the old model.
Yep, old model.
New model.
New model, we actually think that part of the client code is on the server now. It's those adapters.
Right.
And so the client is calling itself across HTTP to the client adapter, and then it triggers a series of server calls to our Java APIs. So that's another key principle there.
So the UI team for each device is responsible for the top two layers.
Yep, for
and the
everything in
API
red.
team is responsible for the infrastructure and the bottom stuff.
Yep.
Okay.
And so if you look at the red parts here, the client code and the client adapter code, actually specifically the client adapter code, that's what we refer to as the data or content formatting and delivery. And the server code is considered the content gathering.
Okay.
And so the gathering part is completely distinct from the formatting. The Groovy script or adapter will call back to the server to get all the content. That gathering can actually be generic, but then we hand it off to each of the corresponding adapters who can format it and deliver it however they want.
So if we look at this from a more traditional architecture perspective, it's almost like this down here on the server code, that's your API, that's your common object model.
Yep.
That's maintained consistently across devices.
Yep.
And the top of it, this is really all the presentation tier.
That's right. And the Java side of it is really, those are Java APIs. You can think of them as, as that as opposed to a REST. We've actually completely gone away from REST. Right. We're still using HTTP when the client calls itself, But all the principles that you talked about above, we're not doing that anymore.
Right. So we actually did get a couple questions.
Yeah.
And I wonder if maybe this is a good question to ask a few of them. Some of these are a little complicated, so I'll get to them at the end. But one person was asking a lot about read and write. So, for instance, what's the difference between the examples we showed? It looked like this was strictly a read-only API. I don't believe that's the case.
It's not the case. The majority of what we do is read,
Right.
because we're rendering presentation layers.
Right.
There are events like ratings and
Yeah.
add to queues and things like that. The majority of what we're doing is read, so this is based on that. Now, the write events still are going through this layer, but the path for those is a lot more simple.
Right. Okay. Cool. So then another person did ask, and I think this is an interesting question, and it'll get to our discussion about versioning, because we may not have time for a long section on versioning. Yeah. How does the client adapter code on the server identify which type of client is making the request?
So they're custom endpoints, and so the PS3.
So literally, it's like a different host name.
No, different URI.
Okay.
Yes. Different URI. So we're not sniffing. We're not doing any of that.
Right.
They are calling a custom endpoint, and they actually have control of creating endpoints on the fly. We're not creating those endpoints through the tool. As they create their new adapters, they upload it. They give it a path name, and it's automatically created. So we built an infrastructure to support their ability to manage their endpoints, create them, remove them, add scripts, all that other stuff.
Okay. Cool. Someone asked, how is authentication done? That is an excellent question for the next section.
Yeah, we'll get to that.
And we'll look more at some of the other questions here. Okay. So one alternative I thought of when we had this discussion was, why not do both? Why not have a REST API and have a mediation layer on top that does this sort of thing?
Right. And
I think we had some.
Yeah, there's another. Logos. And so there are, a YQL or OData or QLIO are examples of.
Or Apogee. Sorry, I had to mention that.
Right.
Stay tuned. But yes, there are a lot of ways to do that sort of thing.
So one of the scenarios, and if we go to the next slide, my viewpoint on that is those are all reasonable solutions and good solutions in many cases. The reason that it broke down for us is that those other alternatives do provide increased flexibility by having multiple different kinds of endpoints or query languages or whatever else. But they're still requiring the server to dictate the rules, and when the server's dictating the rules, everyone has to kind of adhere to them, even though they're more flexible rules. Right. So what we wanted to do was make sure that we get out of the rules business and let the clients define their own rules so they can be more optimal and they can innovate without us being a bottleneck. And that gets to the second bullet there, which is the server team is still responsible for a whole bunch of stuff. And so if you need a new mediation layer or orchestration layer, the API team is more likely to be the team that actually has to build that out. Okay. So you have to do prioritizations and things like that.
But generally speaking, what you've done is you've collapsed the common object model in the same process with the orchestration view layer, and then a very customized I'm waving my hands, which you won't see on the webinar, to the actual devices. There are a couple of different ways you could have done that, and you chose to do it in a way that seems to be highly optimized for performance.
And for distributed innovation.
Right. Because as I understand what you have is you have inside the server, an API call comes to the server. There's Groovy code running in the server that's specific to that device type that actually makes Java calls to Java objects inside the JVM that behind them may be implemented by further APIs or Cassandra or whatever.
Yeah, but we shield them from all that.
Whatever you guys do.
Yep.
So you are still providing an API, but you're providing an API in the form of here's the Java SDK you use to write Groovy scripts and here's the infrastructure to run them.
That's right. That's right. So it is a departure from REST, but it's not a departure from API development.
Right. So this is a very interesting alternative to API development, and I think it sounds like it works really well in your environment.
Well, we're still ramping things up. We have a bunch of devices on it, and we have others in process and others that haven't started yet. So
you also have highly skilled teams on the UI side who you have a good relationship with.
Yes, that is right.
Do you have any estimate? Also, there's a performance impact to this. You've optimized this a lot for latency to the devices and also even server side.
Yep.
Have you done any math about, since you scale a lot?
So in the coming months, we will be publishing, in all
Okay.
likelihood, some of the results of that,
Okay.
of the transformation, but not ready to talk about that right now.
Okay, cool. Sorry, I didn't prepare you for that question. Okay. We're going to talk about a few more trends, and we're going to go a little quick because we actually talked about, I see a lot of questions and a little bit of debate going on, which is really interesting. So let's actually talk about a few things. Why don't we go really, in maybe 10 minutes, through JSON, OAuth, and versioning, and then we'll have some time for questions. So we'll do these three a little bit quicker, since I think the meat of the presentation is what we just talked about. These are kind of offshoots of that whole conversation. First of all, one trend is JSON. You guys all know that JSON is big. And here's what we all know about JSON. We all know that JSON and XML, and I'm being a little facetious here, but JSON and XML are exactly the same. JSON's always smaller, always faster, and all devices can produce and consume JSON. Therefore, why shouldn't all APIs be all JSON all the time? And why shouldn't all API responses be only one particular format of JSON? And we just, I didn't want to make this negative, but say, hey, here's some other things to consider. This first is kind of some of my perspectives, and I think the next slide is some of yours. First of all, and maybe this is more applicable to really, really small devices, not like a PS3, but if every byte that you download to the device is important, not all devices have a JSON library built in, which means now when you install your product, you've got to install JSON parsing code. And someone will tell me that I can parse JSON on only a few lines of code, but you really can't parse it properly without more like a few hundred lines of code. If you really, really want to optimize how much stuff you want to push down to your device, I'll remind you that JSON is not built into JDK6, JDK7, Python versions that are more than about 2 years old. These are not necessarily old enterprise technologies. JDK7 is relatively recent. You could argue it's been in development since we were all children, but you get the point. Similarly, XML documents, important to mention also, and I'm going to summarize some of this a lot and not read every point, is that XML and JSON have very different data models. I sometimes like to point out there are a lot of good tools for XML, that there's a lot of great schemas for XML, but I think that another important thing that I want to emphasize is to talk about the last point here, which is to say that they support different document models.
Yeah, so my view on that last point is that a lot of people have the debate on whether or not you should support XML, JSON, both. That in this world that we see across many devices, saying JSON is not enough of a differentiator. What you really need to say is what is the best, most optimal document model for JSON, in JSON for this particular device? How might that differ for this one? Does this particular partnership require a proprietary structure for the JSON? So you may actually have to, in your API, render multiple different representations of JSON. So the key takeaway here would be make sure you build out a system that can be more flexible in how it's rendering this stuff, so you can add or change it on the fly. And again, it goes back to the formatting and delivery being distinct from the gathering, because as you try to reach more and more devices, that it's going to diverge. We know that.
So JSON is usually smaller than XML, although once you compress it, it's not that big a difference. It is usually faster to parse, but it depends on the device. Not just whether it's XML or JSON, but how is the JSON structured.
Yeah, and if you're, as we are, we're going to be yielding much more payload across the wire for a single request. That means that the object is going to be bigger, and then you start dealing with nuances of if it's truly a deep hierarchy in the object model, what is the device that's going to be parsing that? What are the memory constraints? What's the computing power? Is it going to actually be able to parse that effectively? If your object gets too big, it's going to eat up your memory, and it's going to be a problem. So there are nuances around that you have to consider.
Okay. Cool. I'll kind of dwell on the last part, because I've learned this by painful experience. If you have, for instance, a mediation layer like Apogee, QL.io, you name it, in your API, you can convert XML to JSON and JSON to XML. It seems obvious, but somehow I had to learn it the hard way. It's easier to convert JSON to XML than to convert XML to JSON. because the XML document model is more complex. You've got elements, you've got attributes, you've got namespaces. JSON, you've pretty much got objects, fields, and values, and really only 3 data types. So, when in doubt, using JSON internally is good, but you still may need a mediation layer that can transform the XML or JSON.
Right, but one thing to keep in mind with those transformation layers is that you're basically feeding in a document model, and it's going to spit out another document model that is roughly commensurate with that in the other markup. So it doesn't solve the problem of needing many different types of object models.
Yes, and if you need a wholly different document, obviously you need code.
Yeah.
And that was what you guys have done. Okay. We've had a bunch of webinars on OAuth. I've done them. We wrote a little ebook on OAuth. We talk about it in our book. I pretty much always say the same thing about OAuth. It's really, really important for APIs that authenticate end users for unknown developers. And there are some places where OAuth doesn't make a whole lot of sense. Like for server-to-server communication, you can use OAuth. You could also use two-way SSL or HTTP basic authentication with a big random password. Kind of 6 of one, half a dozen the other. Where OAuth is super important is when a third-party developer is going to build an app that talks to your API on behalf of your end users. Now, you guys have chosen not to use OAuth in your new approach.
Yeah, and you mentioned it. So we have a lot of known developers down the hall building apps that are Netflix-branded apps that we have control over. So we have the benefit of experimenting and doing other things. So we have some devices that are still running on OAuth, but for the most part, we've moved to a secure cookie type approach where a lot of the UIs that we've developed are web-based UIs, dynamic HTML, CSS3, HTML5, CSS3, JavaScript, and they can handle the cookie, pass it to us. We can authenticate on that secure cookie and have a much more simple interaction model on the authentication.
No, do you remember when you guys were designing this, if you looked at OAuth 2 and the bearer tokens and all that stuff instead of the cookie? Because that sounds like a very similar approach.
It's similar. I wasn't actually, that preceded me slightly, so I don't actually recall the discussion on that.
Okay, so it may have been early for OAuth 2. But basically what you're doing is it's a bearer token-like approach. There's a unique random cookie that's passed back and forth and stored on the device rather than the OAuth 1 business.
Yes. Yeah.
Okay.
None of the back and forth. And again, there's an optimal approach that we can get out of just handing off the cookie rather than doing the dance of the OAuth handoff.
Right. So you're basically and this is a situation again where I think OAuth 2 was actually a little bit was still being defined when you guys started building this solution. There is a way in OAuth 2 to pass a username and password and get back a token, and that sounds like what you guys are doing. Okay.
Similar.
Okay, similar. I mentioned server-to-server APIs. We're running short on time, so I'm not going to dwell on every one of these. And we'll mention the other OAuth alternative, which is not authenticating the end user at all. My understanding of the Netflix API clients is that you always authenticate the end user. Is that true, or are there API calls? The old API, there were API calls that did not.
Everything gets authenticated.
And that's in the new model.
Yes, it's critical.
Because what we often say is that for APIs that are totally read-only, get me the most popular movies being watched at Netflix this month.
See, but if you're in a Netflix-branded app, which is what this is designed for, and I should be clear that this new model is for private API usage. So this is not going to trickle out to the public API. It's having random people in the world put Groovy scripts in our servers does not sound like a good idea. So this is all about the private usage. And it's supporting all the Netflix-branded apps. And those Netflix-branded apps are basically people who have logged in, who want to discover titles to watch and then watch them. That is a user-oriented experience. Everything in that experience is...
It starts with you authenticating yourself as a user.
Yep, and then all of the recommendations that we get, all the titles that we yield, they have your user context, so we know how to recommend things to you. We know how to get your queue and what you've watched and all that other stuff.
Right. So this concept of having like a two-legged auth access is really not relevant to what you guys are building in this current version.
That's right.
API. Cool. I'll give you the conventional wisdom on API versioning as we talk about at Apogee a lot, which is include a version number somewhere in your API so that you can change the major revision of your interface. And when I say that, I mean we've been supporting version 1 for a year. We've realized we have to rename a bunch of stuff because it got confusing and delete some old resources. Therefore, now announcing api.foo.com/v2 will maintain v1 for the next 2 years, but please start using v2. That's the conventional approach. Many public APIs use it in the URI. They put it in the host name. Sometimes it's a query parameter. Some of the more pure REST people like to do custom content types, which allows you to have a different version for each individual resource. And again, that's one of those things that to me sounds very evolvable and flexible and very hard to handle on the client. This is what, in fact, in the book we talk about this a bit.
Mm-hmm. We also talk about going versionless for a section.
We do.
No.
So, can an API call have no version at all?
This is obviously an interesting topic, one that a lot of people have opinions on. My view on it is if you can strive to be versionless in the interface between the calling app and the actual API support itself, your maintenance is going to be much simpler, both in terms of the individual versions that you have to support, and I'll talk in a minute about the growing number of versions and the divergence of the code that supports all of that. And so if you can't actually get to the versionless state, having the mindset of trying to be versionless is very much a best practice, because what it's going to do is it's going to result in reduced lazy programming, definitely fewer versions. So even if you strive for 0 versions and you end up with 2, if you didn't have this kind of mindset, you might have ended up with 4 or 5, and that's harder to maintain. And you're going to have a much cleaner system.
So I think the anti-pattern is every time I push a release of my code, it's a new API version. That would be death for people using your API because they wouldn't know when you're make backwardly incompatible changes.
Right. So you want to try and be thoughtful about, does this really require a new version? Things like adding new elements or new data types. Those things don't require new versions.
Adding new URI resources if you're using the REST pattern.
Yeah. Addition usually does not result in new versions. Now, structural changes, they might, but what you can do is be very thoughtful about what you're going to release and to who. So if you're going to release to a large set of unknown developers that you don't have influence in terms of migration paths, in many cases that would be a public developer community. My thought on that is better to be incomplete than inaccurate. So be very thoughtful about the things that you're going to release publicly, and if you don't feel that there's a long view on the way you've built it, hold on to it. Flesh out the ideas, make sure that they're going to be sound, make sure that you have a path for growing that resource or growing those data elements so that you don't have to break it and version it down the road. So taking those kinds of mindsets will really help reduce the total number of versions that you have. And the value proposition on that for a company like Netflix, where we're on 800 plus different device types, many of which are smart TVs and things like that. Average life of a TV by some standard that I got somewhere, I don't remember where, 7 to 10 years.
And that's a newfangled HD TV. Used to be a lot more than that.
Yeah, right. So 7 to 10 years. Some of these you might be able to get flash updates on and get your app so that it's calling a new API and you can kind of migrate them away from older versions. Some of them you can't. And so 7 to 10 years, if you have a version that you have not thought out well enough, you might have to support that on that TV. And similarly, if you think of something like an iPhone, you might feel that you can migrate the iPhone app in correspondence with your API changes, but there's no guarantee that people will upgrade their iPhone apps as well. So there's always a risk that if you deploy something that is not super well thought out and you have to version it, you're going to have to support it in some cases for 7 to 10 years. And as the next slide will show, for Netflix as an example, right now we have the public API 1.0, 1.5, and 2.0. We do have some older legacy devices that are running off of that, and we have other devices, non-legacy, ones that we're constantly updating on those as well. Those are the ones that are migrating to the new world. But you can imagine a scenario where if we continued in the REST world, we're adding a 3.0, 4.0, 5.0, 6.0, and we have to support them all for 7 to 10 years until people start turning those TVs in.
Although what you did instead is you have a different API for each device type, effectively, which means you effectively could have multiple versions. You could even have multiple versions for a device type if you had to make an incompatible change.
Well, the thing is that the UIs are going to be swapping out the server code at the same time they're swapping out the client code. So the only thing that is contractually challenged in that model is the Groovy to the Java API, and we're going to be following the Java API deprecation model, where we're not going to be supporting multiple. We have the close relationship with these UI teams where we can drive them to change in correspondence with our Java API changes.
Yeah.
So we're not really treating it as versions in the sense of the traditional REST API where there's a URI that calls back, you're expecting a very specific payload, and if any of that changes, you version it.
Right. But I guess what I'm suggesting, and I know we're getting to the end here, is you have version 1 of the Xbox app talking to version 1 of the Xbox server code. Now you're on version 4 of the Xbox app, but I haven't upgraded my Xbox.
Some devices have force updates. So
actually the Xbox does, so there you go.
You have to force it. Others are dynamic UIs. So the PS3, for example, that code base is delivered every time from the CDN, and it's where we control that. And so
it's more like a web browser.
It's a web browser. It's a web client.
Interesting.
So we're rendering that. We have total control of the whole experience.
Okay.
So that is what gives us that ability to be more aggressive with our development and our versioning.
But the iPhone,
non-versioning.
I might not upgrade my iPhone app.
iPhone app is also a web client with an Objective-C wrapper.
Okay, so I can't think of an example there, but there must be an example where you can't upgrade the client and you have to have multiple versions.
There are some examples, and those would probably fall into the path of the older REST API type model. Okay.
So I think that's where you're going. So this is an excellent time for questions. Here's actually a good one in the queues, and I'll go to the chats too. Do you find that the user ID and password are a friction on the registration process, and have you thought about other ways of identifying the user and the device?
So that's more about a user experience than an API development.
Yeah.
So not going to address that directly.
As a user, username and password is still the most common thing out there. What I do see is more and more, like with the cable stuff they're doing, is having to go. Like if I want to use the Comcast app on my Xbox, yes, I have both of those things. I have to go to my browser and log into Comcast and get they're doing like OAuth authorization code login.
Yeah.
But they've had to solve the really hard problem of letting you have access to what's on TV, but only if you're a cable subscriber, and it's a different kind of thing. I think you guys are a little bit more, I don't know, I want to say pragmatic, but I think you make it easier for people to get access to your content because that's your business model.
Yeah.
Whereas HBO's business model is making it harder for people who aren't me to get access to my content.
Yeah, other scenarios like leveraging other authentication, like Facebook Connect or things like that are possibilities.
Right. This is probably a good question for a later follow-up, but we mentioned we mentioned latency, and someone's asking, so what is the latency of a request in your system, and can you break it up?
I'm not going to talk about the new model yet.
Right.
The old model, it depends on the type of request. Some requests are going to be more latent than others because they're doing either more complicated algorithmic computation, or they might be, drawing from multiple sources or whatever else. But by and large, we can return a call. Certainly sub-second, sub 500 milliseconds, depending on the nature of it. Some of them are very fast.
But you're trying to get the number of calls down. So as you've said, and I took some of the slides out because I've seen other Daniel Jacobson presentations where you've said you currently have a huge number of API calls a second. It's not necessarily your goal to have more.
Right. In fact, it's our aspiration to... so each individual call will be very quick. Let's say... on average, I think I said 150 to 200 milliseconds. Some of them are more, some of them are less. But on average, if that's it, but you're making a lot of these calls, and a lot of the back and forth happens there, and the clients have to be smarter about processing all of these requests and error conditioning, all of that. What we're trying to do is push that back to the server so that the one payload that we have to deliver is going to be much higher than 150 milliseconds or whatever. Let's call it 500 milliseconds for that one payload, or 700, but in aggregate it's going to be less than the combination of all the other ones. So I'm not going to talk specific about the numbers, but that's kind of the the order of magnitude.
Okay. Someone had an interesting question, actually, because I thought of this too. Now you've basically taken some stuff that runs in your infrastructure, and you've said to your UI team, write script code here. It'll run on our servers. How do you QA that? How do you ensure the quality that someone is not going to just make a script update that blows everybody out of the water?
Okay, so there are two key things that factor in. One is we have a very strong engineering culture at Netflix. We hire senior level engineers, people that have done this for a long period of time. They have to, obviously meet a certain threshold of skill. So we take a lot of pride in the level of talent of engineering at Netflix, and we're always looking for more such engineers if anyone's interested.
So are we.
Right.
No, go on.
So the other key principle here is that the culture at Netflix is very much driven on freedom and responsibility. And so we bring in people that we can trust, and then we go trust them. So we don't trust them to a fault. We do employ some server-side techniques to try and sniff out some problems. We need to continue to build out that infrastructure, but at the same time, we want to rely on the people to innovate quickly and be smart about that, and not have to go through a range of processes that'll slow them down.
Right. Okay.
But it does expose some risk in that a UI team that would write an infinite loop on a client app that would hit our API servers, we can gate that a lot easier than if they have a runaway infinite loop on the server code that could, act a lot faster in bringing down the systems. So there is some added risk there, but we think that with all those other things in place, it's not that big of a risk.
Okay. This whole no version idea, it seems to have gotten people really interested in thinking about it. What happens when the model is constantly evolving? I think you kind of talked about some of that, but what do you do when your object model keeps changing and you don't want to have a new version number for every monthly software release?
Right. So are you asking in the REST world, advice for the REST world, or how are we doing it?
I think how you're doing it in Netflix is probably the best.
Okay, so the way we're doing it in Netflix is we have close relationships with these people, and so we can constantly be in this state of pushing them to evolve as we're evolving the back end. So if we need to expose another set of data, or we have to deprecate certain Java API calls, we'll leave those around until we can drive everybody off of them. And the way we're approaching it is we're basically going to be supporting two sets of Java APIs at a time, the current state and the future state. And so as we're evolving to get rid of or change certain objects in the Java API world, we'll expose the new ones or whatever else. We'll allow everybody to continue to call the old ones, and then we will actively drive them away. We only want to support two at any given time, and then deprecate and move on to the next one, deprecate, move on.
And this works because you're a little more tightly coupled.
A lot more tightly coupled, yeah. And we all have the interest of the same evolution.
Right.
So sometimes I suspect there will be challenges. So some devices have certain release schedules based on partner relationships or whatever else. So we might be bound a little bit by that timing. Others we have to collaborate with, and we can drive faster. So
okay. So thank you very much for joining. We had a lot of fun, and we'll be sure to do more in the future.
Yep. Thank you, Ray.